Audio test 1, 2, 3. Okay, I think we are live. Ladies and gentlemen, welcome to the stream of the Discourager of Hesitancy. Which means we are going to get started. Last year we did raw programming for several months and long streams, no preparation, just show up and write code. I think that's a valuable thing for people looking to get into programming, to be able to see that things don't work, you try multiple things, you fail a lot, and it's all about the process of iterating to a correct solution or a reasonable solution. And programming is frankly boring for most people. So this mini series, this series of mini lectures is going to be dedicated to my nephews, anyone who wants to learn how to program, because I think it could be taught better. So that's what we are going to do. We'll start a little lecture on how to learn programming. I'm gonna give. I've got probably about 3 of these mini lectures planned. I have a longer series of projects to work, but I don't know how it's all going to fit together. Like, this is kind of my first time putting my thoughts all into one place and organizing it. 3, 4, 5 lectures maybe. We'll see how it goes. Also, I've just got a lot on my plate lately with numerous projects, professional and side projects. So I think I'm going to do shorter streams, which is why this mini lecture series is perfect. Forces me to document some of my thoughts in clear, concise, organized ways. Gives me more time to work on some other things. I'm kicking off a big company push for some electromagnetic analysis of high power transmission lines software. Things like that. So things are going to be super busy, shorter streams for a while, and that's what we're doing. So with that said, I think we're ready to get started. This is not aimed at experienced programmers, but you may still find information you find useful as a way of clarifying or not. But this is aimed more towards beginners. So we'll see how that works and see how the comments work themselves out, if I'm still not targeting the right skill level or not. Like I said, this is all somewhat exploratory for me. We will iterate until we arrive at a correct solution. All right, so I think we are ready to get started. Because of the way OBS works, I have to do this. Then I can go to my slides. Like that. Nope, let's see here. There we go, and then slideshow. Okay, we'll see how this works out. So, learning programming, part 1. Today is the 6th of January. I made some slides. I'll post them in. I'm going to upload the video to YouTube in a playlist for learning programming. And this slide deck will be exported as a PDF and available on that YouTube video. So don't feel like you have to take any notes from what's on screen. And what I usually put in slides is a bit of an overview anyways, enough to trip your memory. Not enough for you to reconstruct the entire lecture and all the details. So, outline. This is kind of the before you start programming section. We'll get you started, but let's talk first about what you're trying to accomplish, because your approach is going to be very, very different. If you want to be a hobby programmer, just kind of pick up a thing or two, or if you want to solve certain types of problems, I'll see a lot of mechanical engineers or electrical engineers have very specific types of problems they're trying to solve, and they don't care about the programming itself outside of the context of their problem. It kind of can narrow. So for the hobby and the very specific types of problems, types of programmers, the programming is a tool and not an end into itself. I'm kind of aiming at people that want to do more, right? People want to hone their craft, who want to achieve mastery, or even want to, innovate within the field of programming itself. And so when I'm talking about honing your craft, I think the Ed Catmull quote is just about perfect. Craft is what you're expected to know. Art is the unexpected use of our craft. Um, so you learn different programming languages, you learn different tools, you learn different frameworks, you learn how to do object-oriented programming, then you learn how to do, functional programming. These are all craft. And then the true genius is when you use all of those tools to create something new and interesting and innovative. So I'm kind of aiming at the bottom three goals. If your goal is just to do hobby programming, most of this doesn't work for you. I would say if you only want to solve specific types of problems within your domain, this may not be what you need. But if you want to be a great programmer, I think this addresses some things that aren't explained elsewhere. So we'll see how this goes. Before you start, I have a number of reading assignments. Okay. Let's go ahead and, can I take a look at them without exiting the thing? I pop out of the thing, and I've, of course, lost my mouse because OBS does weird things with mouse cursors. Come on, give me my mouse back. I have to hide the browser. Oh, didn't come back. Hold on. Sorry. Give me my mouse back. Bring it back. There we go. First of all, will it not just open it? Fine. Copy the link. Whatever. This is a great article to read. Nobody should feel that learning to program is a required part of life. Okay? There's no reason for everyone to learn how to become a master bricklayer or a carpenter or to learn shorthand for stenography. Nobody should have to learn phrenology, surgery, nothing. There's no requirement in this day and age to learn how to code. If you don't want to, don't. All right? Also, if you think that you're in it for the money, I'm going to go work for a big FANG company. I'm going to earn millions of dollars and retire early. That happens sometimes, but you won't have the appropriate mindset, I would say, for learning the programming that I'm talking about. It may happen, but gambling on the money side of it without an actual passion for the coding itself is not an appropriate justification, right? The kinds of people who become great programmers often don't make much money, but they do take their programming very, very seriously. I'm aiming more towards that group. So assignment number 1, read this article and decide if you should learn to program. Reading assignment number 2, teach yourself to program in 10 years, right? There are, hour of code things that started up during the, to the early 2000s. Teach yourself to code in 24 hours, etc., etc. That's not what I'm talking about here. This is not a boot camp. It is not a secret to becoming a great programmer. This is fundamental stuff. And you will have to, if you want to become a good programmer, do the time. Okay? We're settling in for the long haul here. And as I always tell my kids, practice makes permanent, not perfect. If you practice well, you will become consistently that level. If you practice badly, you will perform consistently at that level. So do the time, make it quality. Okay, so that's your second reading assignment. Learn to program in 10,000 hours. 3, this one's a short one. We're going to do this one on screen. These are called the 3 virtues of a programmer, according to Larry Wall. The first attribute, the first virtue, is laziness. There are things that computers are very, very good at. And repeating the same action over and over and over again is exactly what they're for. If you apply yourself to programming well, you can automate away many repetitive processes. You should be using the computer for the things it is very, very good at to make your life simpler. Okay? So laziness is the first great attribute. 2, impatience. I'm infuriated at the use of resources these days on my computer. When I look at a web page and I see how much memory it's using and how long it takes to load, and I know how much hardware is sitting on my computer, it makes me furious. It makes me angry. All right? You don't write software to inconvenience someone else, to make their life slower or more difficult. You should be impatient. You should want to write the best software you can. Oftentimes, you may want to be lazy in the wrong way, which generates more work for you later. But you should be so impatient that you would rather do the job right the first time. Okay. Hubris. You need a certain amount of pride in your work and in yourself. Even if you're not a great programmer yet, you should have the hubris to understand that you could become a great programmer and have the pride to strive for that. The wonderful thing about these 3 attributes, if properly applied, is that you can learn them without a computer, without doing a single line of programming. All right? You can look around your life and find things that inconvenience you and find a lazy way to make the problem go away. Okay? So I always tell my children, it is far easier to keep your room clean than it is to clean your room, right? If you are done with a thing and you put it immediately where it belongs, your room never becomes cluttered and never requires an actual cleaning, right? As opposed to the person who thinks they are lazy and just throw everything on the ground and clutter the room, and eventually, you have to clean it. And now you're setting aside an hour to clean your room when you could have been lazy about it in the first place and just taken care of things as they've come up. Okay? Impatience. Not just the computer, but just impatience with inefficiencies. All right? An example might be doing the dishes. It might be a big argument around the dinner table after every meal about whose turn it is, or you could implement something which reduces that interruption in the flow of things. So maybe you create a job chart with a regular schedule and a checklist so that everyone knows what the job is and whose turn it is on which day. Well, now we're not wasting time arguing about it. We're just getting it done. There are even some tasks I've done professionally or in other contexts where my impatience was so great that I didn't want to deal with anyone else doing it. I would just do it myself. Build pipelines I've done because I was too angry at the way everyone else was doing it and too impatient to wait for them to do the official build, et cetera, et cetera. This was all back in the day. And a large part of that comes down to hubris. I can do it better. Why should I wait? Why should I wait for someone else who's impeding my work so I can't get the things done I need to get done? I can do it better, right? A combination of laziness, impatience, and hubris. The wonderful thing about these is you don't need to do programming to learn them. They're just a way of approaching the world, a way of thinking. And you can practice that in life before you ever start learning how to program. So cultivate these 3 virtues. So there you go. 2 reading assignments and a list of virtues to cultivate. Before you start, I would say learn some math. You should probably get through algebra. It would be good to get through trigonometry, depending on what you want to do with your programming, and even more so depending on what you want to do with your programming, calculus. Even if you don't use the skills in math that you learn, a lot of the skills are still transferable. right? So even if you don't have a computer and a compiler and you have, books to learn programming in, you can learn a lot of the ways that your brain has to work by learning math. It's not, a one-to-one mapping of math skills to programming skills, but a lot of those skills are transferable. So learning math is never wasted. And again, depending on your chosen field, you may do a lot of math. Professionally, I have used every single scrap of math I've learned in high school and in college. I've used it professionally. Okay, all the way down to differential equations, calculus, n-dimensional calculus, series, um, all sorts of things. I've used all of it. Two, work some puzzles. If you don't want to, start right away on program, work some logic puzzles, work some math puzzles. There's tons of them online. You can find them everywhere. Sudoku, learn to think through these problems. Again, it's not a one-to-one, but a lot of the skills are transferable. In fact, my dad always said that some people become gamers, but when they became bored with gaming, they learned programming because that was a harder puzzle, right? It was a tougher problem to work through. And it can. Properly applied programming can be every bit as rewarding as video gaming itself. Maybe some fewer blinking lights and ding ding dings when you win, but the satisfaction of working through a very hard problem and solving it can be very rewarding. So you can start by doing some thinking with logic and math puzzles along the lines of Sudoku. All right, if you want to learn how to program, you need to pick a language. And the quote at the bottom, a language that doesn't affect the way you think about programming is not worth knowing. The way that you interact with your programming helps you to think, right? A programming language is a way to think through your problems. I personally recommend that you learn C and Lisp. You learn C because it's the lowest level language that's not assembly that requires that you know what's happening on the machine with your code. What is your code causing to happen on the computer itself? If you want to write good, efficient, safe, secure software, there is no substitute for understanding what the computer is actually doing with your code. Hey, Code 0. I always try forcing myself to do some math in Guile, Scheme, or Haskell. Yep. So yeah, Scheme exactly fits into that Lisp category. Lisp is a language where instead of thinking about the machine itself, you're thinking about what happens with the code itself, and it will change the way you think about it. You will have to master recursion. You'll have to think of your programming language as data itself, and data that you can manipulate, which means you can change the program itself by manipulating itself with itself. You may never use C or Lisp professionally, but the skills that you learn by using C and Lisp on a couple of significant sized projects are valuable skills. We're going to go ahead and go with C in this series to get started. So to get started, you need two tools. You need a compiler and you need a text editor. We'll talk about those in a minute. A lot of people want to immediately jump straight into using an IDE, and I don't actually recommend it. When you're learning programming at the very beginning, your productivity does not matter, because at your skill level, you will never be productive enough to be useful. Instead, your focus should be understanding what's happening on the machine every step of the way. An IDE hides things from you and makes some things easier, but once you know how things work, if the IDE gets broken, which happens all the time, you can still do things manually. When an IDE does go wrong, you might then know what's going wrong and how to fix it. But when you start off, there's this temptation to try to be productive, to not think about the environment that you're in, and that's wrong. You should learn your environment, then add tools that you need to make you more efficient when productivity becomes a concern and not the learning. And again, it comes down to just time in the system. I think people jump too early into using an IDE. You don't need it. So to get started, if you're on a Mac, you have to sign up to be an Apple developer. I'm not going through that for you. You can sign up to be an Apple developer. download Xcode. Once Xcode is installed, then you go to Brew. Homebrew is so the Mac Homebrew package manager. You can install Homebrew, and then somewhere on a command line you can run this command, and it'll install GCC, which is what we're using. Okay. On Linux, you almost always come with a package manager. In this case, most of the time it's apt, and by most of the time I mean on a an Ubuntu or oh gosh, I don't remember. Anyways, depends on your distro. If you're in Linux, you probably know enough to be able to use the your appropriate package manager to install whatever. But on Ubuntu, this is kind of what it would look like. Every Linux is a little different, so this is not a universal solution. Windows, which is what I'm starting with. I usually start with msys2. I just download and install it. Let's see. Yep, so it walks you through the whole process. Put it in, run msys now. Blah, blah, blah. What I usually do is I add certain msys directories to my path. So we can take a look at that briefly. I don't want to get bogged down. What's the best way to show this? Maybe we go to this view. So when I right click on this PC, properties, advanced system settings, type in my password, hopefully you don't see it. Environment variables, then the path variable. What the path variable does is it tells Windows what order to check directories for a command. So down here, we've got a bunch of stuff. Where is msys? I know I have it in my path somewhere. Maybe it's in this path? No. I swear it was this path. Oh, let's see. msys, here we are. Didn't see it. So this is where I installed to c:/msys64 user bin, and then yeah, I have a bunch of different environments. So if we want to look at what's in this directory, we can actually see what kinds of things our computer will find when it goes through the path. So it's going to find things like, I'm looking for here, G++ and GCC. These are things that we are going to use, okay? So when we said, hey computer, in my path, I want you to put this directory, all of these tools are available to me on the command line when I put this path in my directory, which means we can get to GCC, which is what we're going to use today. All right, hopefully that helps things a bit. Okay, so we install msys2, and then the other thing is you need a text editor. Notepad++, you just download it. Dead simple, whatever's free and easy. And it looks something like this. It's just a text editor. Doesn't do anything too fancy, keeping it simple. Once you have msys and your Notepad++, again, if you're in Windows, you can bring up a command line tool and just make sure that your path is working by typing GCC version. Okay, I've got an old version. I haven't updated it in forever. But I'm using GCC 11.3. Nothing we're using should require a special version of GCC, but that's the environment I'm working in when I'm teaching here. Okay, so let's put that off to the side. and go back to looking at this. Okay, so that's it. You need a compiler, in our case, GCC by way of MSys2, and Notepad++ for our text editor. On the Mac, you can search. There's a whole bunch of different, code editors on Mac, Sublime and Atom and whatnot. You can even get Visual Studio, but like I said, don't use an IDE to get started. We'll start simple enough that you don't need one. And then on Linux, you have to use your installed package manager. Okay, and that's good. Okay, hello world. This is where all programmers start. When you start a new programming language, you start with hello world. I'm gonna let you look at that for just a minute while I take a drink. Okay. Whoop. Oh, back. Here we go. So what we're going to do to start programming is we're going to make a file called main.c somewhere. It doesn't matter. We're going to put this code into that file. Then we'll run GCC, which we just looked at in its directory, main.c, and it's going to create a program that we can run. We'll talk about all this in more detail. Let's get started. So I'm going to hide my browser. This thing we will hide for now. Okay. So in whatever your text editor is, oh, wait a minute, I'm going to use Notepad++. We're not going to use Emacs. That's a later lesson. I'm going to hide that. Where's my Notepad++? There it is. Let's make it a little bigger, move it around so you can see what's going on. Okay. So we're going to make a new file. And we're going to get that code off of the slide. It's simple enough that I don't need the slide, but we're going to pound include stdio.h. I'll explain all that in a minute. Int main printf hello world. That's it. That's all the code we need. So let's put that on my desktop for now. It's fine. And we're going to call it main.c. Okay. That's it. That's all the code you need. Once we have that typed in, we come over here to our command line window. Let's see, can I make that a little easier to see on that black background? Okay. And I'm going to go to our desktop, GCC main.c. The name of this file doesn't matter as long as this name matches this name and we're in the same directory as the file. Okay? We can name it anything we want. By convention, we use main as the name of the first file that we compile. We run it, and we don't see any errors. If we'd done something wrong, we would get an error. So we can, for example, return 0, and I'm not going to put a semicolon at the end, and I should get an error. It says, hey, I expected a semicolon before this thing on line 6. So I can come over here to line 6 and say, oh, there's a curly brace, and this, it expects a semicolon. Okay? And then our compile works again. What this compile does is it takes in the code here from whatever file you specified, and it takes the human readable form that you typed and turns it into something the computer can recognize called a.exe. on Windows. If you're on Linux or Mac, it'll probably output a.out. And we're just going to run it. And look, when we ran this program, it outputted to the console, hello world. And then we're done. And that is it. You've programmed and compiled your first program in C. So let's take a look at this. This, count include, is how you get other pieces of code into this file. Okay? Now, stdio means standard input output. And it means that somebody's already written code here to do input and output type things. So we don't have to write this code. We can just use it. So this is called a library, or importing a library. Pound include, and this is a built-in library. Okay, I didn't have to do anything fancy to install it. It automatically comes with a C++ compiler or a C compiler. Int means it's an integer that this function called main returns an integer. And these parentheses mean that there's no input to this function. We'll talk about all this in time. Then everything between these code braces tells you what this function does. Okay? And the first thing it does is it calls another function called printf, means formatted printing. And we give it a string. We said hello, comma, world, exclamation mark, \n. This is a special character that means go to the next line. If I don't put this in, it'll write out hello world, and then the program's done, and then it'll write out the next prompt right there. So we always put a \n when we're doing printf. Oops. And then that's the input to this function called printf. Semicolon tells the compiler this is the end of an expression or statement. This is the end of something we want you to write code in. So in English, we use periods to denote the end of a sentence. This is kind of the same idea. And then we say return 0, right? Because we told it, hey, this function called main, it has to return an integer. Well, here's your return 0. By convention, return values of 0 means there was no error. Anything that's not 0 means there was an error. If I return 42, other programs would probably report that as an error, whether I intended as an error or not. So by convention, it's 0. 0 is the one that means everything succeeded correctly. And that's the overview of programming. Just getting started. Okay? So going back to here, we created a file called main.c. We put in all the code. We compiled it with GCC, that's the GNU C compiler, and told it to use our file, and it automatically created a.exe as our output, which we executed on the command line. All clear? Everybody good? Yes, a.out by default on Linux. Yep. All right. Good, good. So no questions. So let's move on to what I'm calling black box abstraction. When we're learning to code, a lot of the times there will be pieces that you don't understand, and we're going to brush past them. Here's an example. Main.c, you know what it is. It's a text file, we typed it in. Our code is to tell the computer what to do. But computers don't speak this language, so we pump that file into a black box called GCC. When I say black box, I mean you can't see inside of it for now. We're going to pretend like magic happens here and out pops something else called a.exe. So when I say we're going to use GCC as our compiler, I'm assuming that you're going to just kind of brush past what GCC does for now. We'll dive into more and more details and peel back those layers. Especially in the beginning, like there are models of thinking that I will tell you that are wrong or incomplete, but it's okay because we're going to build on them. So here's one. You take your text file of code, you dump it into a black box called GCC, and pop, out comes an executable. Okay, magic happens here. We'll talk about that magic later. Here's another example of a black box abstraction that will help you in this exact code file. When we said printf hello world, what we're doing is we're saying, here's an input called hello world. It goes into a black box called printf. That pound include stdio.h that we have in our code file here. Pound includes stdio.h. This is a black box. We don't know what's in here. And it tells us there's a function called this. We don't know what this function actually does. Maybe it adds up a bunch of things. Maybe it creates a lot of memory. Maybe it doesn't. We don't know. We don't care at this point. We're just using it. Take this input, dump it into a black box, and it writes stuff to the output in the console, right? That's what happens in this case. So a lot of the things we're going to talk about, I'm going to say this is a black box for now. We can peel back those layers and look inside the black box later, but it's more of an as you're ready for those things. I don't want to overcomplicate too much early on. So that is the end of the first mini lecture on programming. If anyone has any questions, I'm happy to entertain them. Syscalls lower. Yeah, we're not going there just yet. This is more targeted towards like my nephews who say they want to learn to program. We'll keep it simple. We won't talk about the difference between system calls and library calls. Statically and dynamically linking. Super cool. Yeah. So we're going to just post this up to YouTube. The slides will be attached to the YouTube video. There'll be a new playlist in the Discourage Your Hesitancies playlists. We'll have a new one called, I don't know, beginner programming or something. And yeah, we're going to build on this a little bit over the next day or two. Short streams, short lectures, just overviews, get things started, get things moving. Yeah, so we're going to try that out for a while, a week or two, and see how many lectures we can get done. So any questions, let me know. Otherwise, I'm going to wrap this up. You can put questions in the YouTube video once this gets uploaded. That also works great. In the meantime, I'm going to disappear and go work on other projects I've got cooking. So you have a wonderful day, and I will see you in the next lecture. Bye-bye.